Hi all, welcome to the ninth lecture on mechanics of machinery. In this lecture, we are starting our fourth module. As I already told in the last lecture, we already completed the first module. Now we are skipping the second and third module. Now we are going directly to the fourth module covering the gears. Fifth module is gear train. So 4 and 5 are somewhat related. So here we are going into the gear drives, various types of gear drives, law of gearing, and so on many things related to gear drives. Okay, so let's start with mechanical drives. What is a mechanical drive? First, before going directly to the gear drive, we need to know what is a mechanical drive. As a definition, mechanical drive is defined as a mechanism which is used to transmit mechanical power over a certain distance. So mechanical drive is mainly used for transmitting mechanical power over a certain distance, usually involve a change in speed and torque. Normally the input as well as the output speed is not same. Normally the input and the output speed or the input and the output torque is usually not the same because it will change during the transmission. So again, mechanical drive is used for transmitting the mechanical power over a certain distance, usually involved with a change in speed or torque. Now, what are the different types of mechanical drives? Belt drive, rope drive, chain drive, and gear drive. And in this module, we are focusing mainly on the gear drive. Okay, so why or where are we using all these mechanical drives? So, or what is the practical importance of these mechanical drives? Or where you can see the applications of mechanical drive. See, there are many situations where the torque and speed of the machine are always different from that of the electric motor or an engine. That is, like if we are using an electric motor to run a machine, and the speed of the electric motor is different from the required output speed of the machine. Maybe the machine needs to run at 500 rpm and the rpm and the speed of the electric motor is 1000 rpm. Machine needs to run at 500 rpm but the speed of the electric motor is 1000 rpm. Then we these drives can be used for transmitting the mechanical power as well as changing the speed or the torque. So this type of application you can normally find in an overhead traveling crane where the electric motor is running at a different speed than that of the output speed, than that of the required output speed. Okay. And next one is variable speeds are required for certain operations whereas the prime mover runs at constant speed. The perfect example is lathe. This sentence meaning that the lathe is usually run by, maybe you assume that the lathe is run by an electric motor and it is running at 1500 rpm. Now the spindle or the headstock needs to rotate at different rpms. Like the headstock needs to rotate at 500 rpm, 700 rpm, 1000 rpm, and 1200 rpm. But the speed of the engine is always constant, which is 1500 rpm. In such cases, we can use the mechanical drives. Okay, so this is another application of using the mechanical drive. Which drive I am using in this particular application, that needs to be selected considering various other criteria that we will come in the later section. Okay, so here also we are using one mechanical drive for transmitting the mechanical power. And there are also cases in which the linear motion with various velocities or varying velocities are needed, whereas the motor usually rotates at a single rpm. I hope you remember the application we studied in the last lecture, Whitworth quick return mechanism. I hope you remember the application of Whitworth quick return mechanism. Shaper. You know that the shaper needs to execute the linear motion at varying velocities. That is, the forward stroke is greater than the time for the forward stroke is greater than the time for the return stroke. Okay, so in such cases also we need a drive, mechanical drive. Okay, so these are the some of the few applications of mechanical drive. Now let's look into the broad classification of mechanical drives. We can classify mechanical drives in many ways, but this is one way of classifying the mechanical drives. Mechanical drive transmit power by the means of friction. Can you imagine what are those things? Transmitting power by the means of friction. Belt and rope drives. You know, the belt is connected to the pulley and the friction plays a very important role in belt drive. So belt and rope drive is one example in which the power is transmitted by the means of friction. And power transmitted by the means of engagement. I hope you are familiar with this classification, the chain and gear drives. You can see that in the chain and gear drives, there is an engagement. The gear drive, there is an engagement of the pinion and the gear. In the chain drive, the chain engages with the sprocket. So here the power is transmitted by the means of engagement. And as I already just mentioned in the previous slide, how we select a proper mechanical drive. If we have an application, then on what criteria we select a mechanical drive among the various mechanical drives available. First, we need to look at the center to center distance. If the power is to be transmitted from one point to another, that is the center to center distance is very high, then obviously we need to go for the chain drive, rope drive or belt drive. Whereas if the center to center distance is very low, we can go for gear drive. These all aspects we will discuss again once we go deeper into the gear drives. Anyway, I am mentioning this broadly, that's all. Velocity ratio. I think you are not familiar with the term velocity ratio at this point, so we will discuss what is velocity ratio and how it significance, how it is significant in selecting a proper mechanical drive. That all we will aspect once we go deeper into the gear drives. And shifting mechanism, how to shift the, if you can see that in automobiles there is a gear shifting arrangement. Similarly, if you want to shift the belt or the rope drive, there is also a mechanism, so that also needs to be considered while selecting a proper mechanical drive. And maintenance aspects we need to consider, whether it is a complicated maintenance or simple maintenance is needed, that all we need to consider. And finally, whether a particular mechanical drive is economical or whether it is compact in this particular application, this also we need to consider. Now let's move into the gear drives. This is what we need to study in this module and the next module, that is in the fourth and fifth module. We need to concentrate on the gear drives. So let's focus on the gear drives. How can you define a gear drive? Gears are defined as the toothed wheel which transmit power and motion from one shaft to another by the means of successive engagement of the teeth. I think I don't need to explain much regarding this definition. It's very clear definition. It's a very clear definition. Gear drive is used for transmitting the motion and power from one shaft to another by the engagement of the teeth. And what are the advantages of gear drive? Almost all the advantages and almost all the disadvantages are self-explanatory. I'm not going into that much too much detail. It is a positive drive and velocity ratio remains constant. Just keep this in mind. Gear drive is a positive drive, chain drive is a positive drive, whereas belt and rope drive are not positive drives. Velocity ratio remains constant in gear drives. This aspect I will explain in the later stages once you study what is velocity ratio. And next thing is center distance is relatively small, because as you all know, if the center distance is very small, then only we can use the gear drive. It transmits very large power. Since it is a positive drive and the velocity ratio remains constant, it can be used for transmitting very large power, because here the power is transmitting by the means of engagement of the teeth, not by the means of friction. If it is by the means of friction, then there is a limitation in transmitting the power, but here that is not the case, and so it can be used for transmitting large power. It can transmit at very low velocity, The efficiency of the gear drive is very high compared to belt or rope drive, and the provision for gear shifting is also possible in gear drive, and it has a reliable service. These are the advantages of gear drive. And coming to the disadvantages, one of the main disadvantage is the manufacturing. Manufacturing of gears requires special tools and equipments, and therefore it is costlier than the other drives. Okay, here specialized hobbing machine is available for manufacturing the gears. Even we can cut the gears in our milling machine, but they are all complicated. So the manufacturing is little bit complicated and expensive, and so that is one of the disadvantage of gear drive. And error, if there is any error happened during the manufacturing, this may cause vibrations and noise during the operation. And also the maintenance is little bit worry for the gear drive, because it requires suitable lubricant and reliable method of applying it. Otherwise there will be a big maintenance part for gear drives. Okay, so lubricant is very important in gear drive, whereas it is not that much important in belt drives or rope drives. Okay, so these are the advantages and disadvantages of gear drives. Now let's look into the classification of gears: spur gear, helical gear, bevel gear, and worm gear. In this section, I am just giving a rough idea on what are all these four types of gears. Later, we will go deeper into each of these things. First, we will study spur gear in very detail. Then we will move to spur gear and helical gear in very detail. Then we will move to bevel and worm gear towards the end of this module. Okay. Now, I am giving a brief explanation of what are all these types of gears. So, the first one, the spur gear. As you see, this is one case of spur gear. Here, the spur gear is used for transmitting motion and power for the two shafts which are parallel and not intersecting. The shaft, these are the two shafts. These shafts are parallel, they are not intersecting, and they are on the same plane. So, spur gear is used for transmitting power between two parallel and coplanar shaft. And you can see that the teeth of the spur gear are parallel to each other. This teeth is parallel to this one. Okay, so this is the uniqueness of the spur gear. It is used for transmitting power between two parallel and coplanar shafts, and the teeth are parallel to each other. Okay, so this is the spur gear, and here comes the helical gear. You can see from the animations, the only difference between the helical and spur gear is that here the teeth are inclined to the axis of the shaft. You can see the inclination here. The teeth are inclined to the axis of the shaft, and so it is called as helical gear. This is one animation. And in this figure, when you notice that the teeth are inclined, but inclined in both directions, one in this way and another in this way. This is also a classification of helical gears, but we call these as double helical gears because the teeth are inclined in both the direction. So it's a double helical gear, and this is a helical gear. Here also the shafts are parallel as well as coplanar. And the third one, bevel gear. Bevel gears are mainly used for transmitting power between non-parallel and intersecting shaft. Non-parallel and intersecting shaft. Here if you look at this animation, you can see that the two shafts are not parallel. Actually they are at 90 degrees, they are perpendicular and they are intersecting. So the bevel gears are used for transmitting power between two non-parallel intersecting shafts. And this animation and this one is an example of Mitter gear. I think you don't need to confuse with the Mitter gear. Just I will explain what is Mitter gear. That is, if the two gears are identical and if the shafts are perpendicular, then they are called as Mitter gears. Actually that is the bevel gear only, but we call it as Mitter gears. So the condition is the two gears, that is this one and this one, needs to be identical and they are used for transmitting power between two perpendicular shaft, then they are called as Mitter gears. It is just a classification of bevel gear only. So basically, roughly saying, the bevel gears are used for transmitting power between two non-parallel intersecting shafts, and the teeth are always inclined at a certain angle. So this is also another example, another image of the bevel gear. And here, when you closely look, this is also a bevel gear, but when you closely look, you can see the difference. As I already told, bevel gears are mainly used for transmitting power between two non-parallel intersecting shaft. But here you can see that the two shafts are not intersecting. So this is also a classification of bevel gear. This type of bevel gears are called as screw bevel gears. Screw bevel gears means two non-parallel, non-intersecting shafts. Motion is transmitted between, or the power is transmitted between two non-parallel, non-intersecting shafts. And last one is the worm gear. This is a different type of gear. Here we have a worm shaft and a worm gear. So it is more like a threaded joint. This worm shaft looks more like a threaded joint. Okay, so this is the worm gear. Here also the shafts are not parallel and not intersecting. The two shafts are inclined at a certain angle. So it's also a parallel, non-parallel and non-intersecting. Okay, so these are the basic classification, in one way of classification of gear drives. From the next lecture onwards, we will focus more on the spur gear, and towards the end of this module, we will focus on the bevel and worm gear. Okay, so next class we will look into the various terminologies of the gear drive. So that's for today. I am Vipin Goban signing off. Thank you.